Hey everyone, Doug here with Process Technology out of Salt Lake City, Utah. In the previous session, we covered these topics. Let's continue the deep dive into operator experience. There are three approaches to maintenance. Go to failure. Surprisingly, this is still in place for some facilities. Proactive. Send a technician out at routine intervals to service loops regardless of whether they need it or not. This is not a good use of resources, people. And thirdly, predictive. Why not let the loop inform you of whether it needs attention or not? In this case, the operator is at the mercy of the transmitter and what diagnostics it presents. Think about pre-9/11, that's 25 years ago. All you had was an error code displayed. No one knew what it meant, couldn't locate the manual to find out. Most of the time, it still didn't tell you what was needed, so you just replace the sensor and move on. Great for sales folks, bad for maintenance budgets. Just after 9/11, Mettler introduced a revolutionary graphical diagnostic feature, the three faces. Smile means it's all good, neutral, it's trending away from good, and sad, I've got issues. Mettler promoted this as if it's smiling, you keep on walking. Otherwise, you need to stop and do something. It really wasn't always clear what you were supposed to do, or specifically what was the issue. Do you clean the sensor? Was the glass cracked? Reference junction clogged? Needs calibration, etc. But still, 20 years ago, this was a huge improvement. However, the Mettler team realized this wasn't addressing the operator's needs, which is, when does the sensor need to be cleaned and calibrated? And more importantly, how much longer will this sensor last? Not as some percent in a wear monitor or a letter code you have to interpret.
The ISM predictive diagnostics that Mettler-Toledo provides on their sensors is extremely powerful. It literally is reading out in terms of numbers of days, in terms of what actions need to be taken. Here's a sensor connected. It's a relatively new sensor that's connected. My DLI, my dynamic lifetime indicator, this is calculating how many days of life is left on the sensor. When you attach a new sensor, it takes 24 hours for that to occur. We can actually have that tell us that we have 21 more hours before my DLI algorithm is going to give me the calculated number of days that the sensor has. If I want to look at a bit more information, I go into two steps, ISM, iMonitor. Again, here it's telling me you've got to wait 21 hours before your DLI is going to show as a value, and it's also going to determine how much longer it would need before it needs to be calibrated. Those are both being calculated as we speak. Important information is impedance values on the glass, which is the RG, and impedance on the reference. These would be pertinent to sensors that get fouled in the process, coating, and therefore need to be cleaned. Clean then improves my calibration. So here's a sensor. Let's look at an algorithm off of a simulator, which is going to mimic some bad values, just for diagrammatic purposes. All right, so let's hook up this simulator and see what we get. We'll say, yes, we have a new sensor. And in this case, it's going to give us a pH value. We'll assume that it's a real value, but I've got a red bar flashing. That temperature may be unrealistic for this operator based upon their process. But if we look at some of the information, we can go into the red bar. We can see, oh, that sensor needs to be calibrated. And by the way, I've got some other issues. My impedance values on the reference and glass. Reference is shot. Glass is on its way out. Needs to be calibrated, and its life is essentially expired based upon the algorithm. If we go back here, we can see that information in the same manner under the iMonitor, but all in one view here. So we can see that the lifetime indicator says there's nothing left on this sensor. If you want to try to calibrate it, you really need to try to clean it first because your reference is shot. The glass is on its way out. And if you could improve these, you might be able to get it to calibrate. But the odds are this is indicating that the sensor has actually failed in the process and needs to be replaced. So again, you actually will have numbers of days presented, even on the display if you set it up that way. And this could also be sent through 4 to 20 on the analog outputs, or if you're using Ethernet or field bus, all of that information is carried through on the digital bus platform. So you could see this in a control room.
Because the Mettler sensors are digital ISM, intelligent sensor management, they now can connect and use a digital asset management program on any PC or tablet.
Let's look at Mettler-Toledo's asset management tool, which is this IIIb core software that you can load on a PC or a tablet. When the program first launches, we're basically using a USB connection and a standard connection with a sensor. So we've already seen the handshake in an earlier video. When I hook up a sensor, that's simple. Put that probe into some water. Like this transmitter, the program immediately recognizes there's a sensor attached. It's showing us the part number and serial number for the sensor while it reads the data off the sensor, and then it populates this field. Literally what we have is color indications, all the details for this sensor. According to this algorithm, it has 380 days left. This is a demo probe that's probably been in and out of a briefcase for 2 years, but it hasn't seen process, so a lot of the conditions are still really good. If we wanted to look at the slope and the zero, we can look at ISM monitor, and we can see a slope value anywhere between 90 and 102% is considered good. We can see where it sits. Same with the offset. If we go back to details, we do have a yellow indication on the reference. We can determine what that is in a second. But the program literally will show you immediately what's going on with this sensor. The idea here is to do a calibration. So we're going to go right here into this. We'll look at what the settings are. We're going to do a 2-point calibration, but you can see other calibration menus that are available. The buffer set, I know some of the programs out there, you have to manually load these. These are all automatically provided from Mettler-Toledo. If you wanted to use some other solutions from other providers, they're not forcing you to use their buffers. You can buy it from Hawk, you can get it from VWR, Fisher, Thermo Fisher. I typically just use NIST Technical. That's the one I use by default. That gives me 4, 7, and 10 for my buffer recognition when I'm doing temperature compensation. So we go back to calibration. It literally is prompting me what to do. It's telling me to put in the first buffer. I'm just going to drop it into 4. It doesn't matter which one you're putting it in. And then we'll say continue. And then you can watch the graphical interface. We've got a wheel indicating that it's trying to figure out what the sensor is sitting in, because it didn't tell me to put it into buffer 4, 7, or 10. It will recognize from the millivolts that in this case it's buffer 4. And then we have a sort of a stability indicator that's built into this. So this little shape here is actually going to move down in terms of the rate of change over time. It's looking for a stable, minimal rate of change over time before that will lock in. So we just have to wait for that for a few seconds. And you can see how it's rapidly dialing in, getting to a more stable reading, probably. And we can see that it passed the first buffer check. All right, it's prompting us, as you can see on the display, put it into buffer 2. Let's do a quick little rinse. Good technique. Drop it into the next buffer, and then it tells me to click continue. It's going to sense the millivolts that it's in, determine what that buffer is, and then present that to us, and then do a stability check before either accepting or not accepting the calibration. So I mean, it's pretty quick to recognize that it's in buffer 7. And we can see it locked in on buffer 7. What it does at this point is, because the dynamic lifetime indicator is dynamic, it will add or sometimes subtract days of life. But this case, it says the adjusted DLI is still sitting at 380 days. Again, this probe has not seen any process. It's just been sitting in and out of buffers. So there we say continue, and it then shows what the data is for this sensor. So the current calibration here is in the center, gives us the slope, the offset, etc. I'm going to say adjust sensor. This is if I wanted to add a comment like, hey, this sensor is going to be installed in, the alky unit at the refinery, whatever. I could say and put that information in there, but I'll just say skip. And we wait for the sensor to have the new slope and offset data loaded onto the head of the sensor. So now it's married to the sensor, not the transmitter. In the days of analog sensors, which a lot of people still have, you can't do this. The calibration data resides in the transmitter. All right, at the end of this, if I want to see a report, I can click on this button here, and it will load a PDF report of this sensor and give me the actual calibration data. Might be hard to see here. I'll zoom in on this in a second. So we'll just close out of this. And that's as simple as the calibration. If we wanted to look at some of the data a little bit deeper, there's some more functionality. Like if I wanted to look at the previous calibration on the slopes, there are some slope values that are captured and shown graphically. So within this green bar, I've got several calibrations. You can see the sensors from 2023, actually almost 3 years old, essentially, April 14th. So we can actually graphically see how this slope is performing over time. Same with the 0 point. We get this graphical view. So if a sensor was in the process, most likely we would see trending to where it's going into the yellow areas, either above or below that. Another function of the ISM core software is that it actually acts as a database. So here's how you can actually track and manage the assets that are used at a specific plant. If you've got like 2 pH sensors in your facility, this isn't that big of a deal. But when you're in a refinery or other facilities where you've got 10 to 100 or more sensors, having a database is a way to actually manage these assets. I don't have to have a sensor attached. I go down here to where it says database, and any sensor and all sensors that are connected to this will be registered. So these are just sensors that have been attached over time. If we look at the probe we just had, which was this one at the bottom, I can click on a function here to get the report of this sensor. I can zoom in a bit here. And what we can see is actual data from this sensor. When it's taken out of the box and calibrated for the first time, this is really important for end users. When they do that first calibration, it's burned into the memory permanently. It's called the first adjustment. The reason that is because that's the baseline data that all data of the sensor aging is compared to. Down here we have reference impedance, glass impedance. What are those values on day one? And as the sensor ages, it gets coated, high temperatures stress the glass. Those will be impacted on the reference and glass impedance, and those values will be tracked. And how they differ from the first adjustment is what determines whether the sensor needs to be cleaned, whether it needs to be calibrated, or whether it's actually no longer functional. And we can see the same for the slopes that are captured here and the offsets. If there was a sensor installed in a process and we had a high temperature excursion, that would be captured. You can see a lot of data in here. It's all provided automatically. Let's look at an example of another sensor that actually had an interesting finding. The customer didn't realize they had a temperature excursion. So if we zoom in a bit here, here's an example where down here where it says sensor max temperature, what was captured was a temperature that exceeded the limit of that sensor. This sensor doesn't handle this high temperatures, and they actually exceeded it and they didn't realize it. But this was a way for this program or the sensor and ISM technology to automatically capture that. The sensor was in operation for only 94 days, and surprisingly, the DLI was reading 0 days. There was a lot of other issues with this sensor. We had a relative change in our impedance values, but mostly that high temperature is probably what determined that this algorithm and killing this sensor and showing 0 DLI days. So it has more use than just as the storing of the data and having reports of the sensors, which could be provided. If you ever needed to report stuff to government regulations, you actually have reports that come out of this program that are automatically created. You can even export them down here using a function for putting them into Excel for tracking purposes.
Meltler was the first to introduce the hot swap concept. This was more than 20 years ago. It was a manual process that let you calibrate a sensor and write down the slope and the offset. You then had a menu option in the transmitter for data entry that let you manually type in the slope and the offset. With the development of digital ISM, anything manual is a thing of the past.
Earlier, you saw the digital handshake of a sensor being connected to a transmitter. You saw how we performed a 2-point calibration using the ISM core software on a PC. The hot swap concept is calibrating sensors in an environmentally controlled instrumentation shop, INE, ENI, whatever. And then simply go into the remote installation and in minutes swap out the pH transmitter. So here's an example with that sensor still connected to the software we just calibrated in the shop. We will disconnect it and connect it directly to our transmitter. Say we jump on our truck, on our bike, whatever, go out to the loop. We'd uninstall the initial sensor that's out there. We'd pull it out. We'd swap the sensor. This is now saying, hey, you have another sensor on here. We accept it. It does that electronic handshake. It will actually then load the calibration data and everything associated with that sensor and go right into measurement mode. So the sensor you just swapped out gets taken back to the shop for a clean and cal and literally can sit for a month until the next loop needs a swap. Most folks simply rotate a couple of sensors through and find they extend the overall sensor life by doing it that way.